From the get-go, we are actually going to be going through a test that is basically grade 10 oriented. So for all the learners that are here that want to basically revise for the upcoming controlled March test, then you are in the right life, because we are looking at a test sort of like with term 1 sort of like test. Okay, so here's the test, guys. This is it. All right, we are looking specifically at a grade 10 paper. Grade 10, guys. Grade 10. We are grade 10ing all the way. Please, guys, share the live with any grade 10 learner that you may know that may benefit from a live like this. Share it out and share it out very loud. Okay, yeah. And let's gift yeah, so this is just an example. It's not the I don't want people here making predictions or thinking that this is it. No, it's not. This is just an example of a grade 10 March test. So basically we're going to go through it and we are going to answer it so that people can actually get a feel as to grade 10 March test example, if you want to call it that. Yeah, so if you're in grade 10, in the right place, share the live with any friends that you may have that are in grade 10 that may benefit from this. Okay, let me. Yeah, okay, so let's look at this together. All right, so please be proactive in the comment section if you are in grade 10, a grade 10 learner. Like I said, this is not the March exam or March test, control test that you'll be writing at your school. This is just an example. It's an example test. Please, guys, don't come here and comment and say, this is the test. No. I don't even know which province you are in. I don't even know what your teacher is thinking. So your teacher may be thinking something completely different. But share the live with people that are in grade 10, that are your friends, your mates. We'll be running this live up until 12 o'clock, from now until 12 o'clock. So come in, tune in, and participate in the comment section as much as you possibly can. If you are feeling sleepy, too bad for you. So the first question says, given P. You see, given P. Share the live with your friends that are in grade 10. Share it out, guys. Share out the live. Let them come in, and please, if you can, do gift. I have a live gift goal, guys, of you awesomes, 100 you awesomes and 1,000 roses. So if you can support the live with roses and you awesomes and any gift that you can, that would be great. If you can't gift, double tap on the screen. Like I said, share the live, repost it to your friends, your family, your uncles, your aunties, and anyone that might benefit from a live like this. Okay, it's for grade 10, guys, not for grade 11, not for grade 12. It's for grade 10. If you're a pure maths student, for grade 10. If you know people that are doing pure maths grade 10, share the live with them. They need this. It will benefit them, all right, because it's good revision. You may be writing your test next week or next week, or whenever you're writing your test, whatever province you are in, you are going to benefit being in this live. So let's look at the first question. Given that P, the P is equal to the square root of 9 over 11 minus x, and it says where x is an element. Now, guys, this thing here, when they say x is an element, it means x is. This is like a symbol that means x is. So if you're speaking in layman's term language, you are saying where x is, or the values of x can be. And look at the values that they've listed, guys. These are the only values that they've listed, from smallest to biggest: -11 and -5 and 0 and 15. These semicolons that you see here mean and. Okay, so they are saying P is equal to the square root of 9 over 11 minus x, where x is negative 11 and negative 5 and 0 and 15. Now they are saying which values. Okay, please take note, guys, that they are saying for which values. All right, this value or values, it's saying it can either be a single number or it can be many numbers. For which values of x is p 1.1 a rational number? Which value of x here will make p? What is p? P is the square root of 9 over 11 minus x. Now they are asking which values of x is p going to be a rational number. So now if you are a grade 10 learner and you still to this day don't know what a rational number is, my guy, my girl, you are playing around. Remember the definition of a rational number. A rational number is a number that can be written as a fraction where the numerator and the denominator are integers and where the denominator cannot be 0. I repeat, a rational number is a number that can be written as a fraction where the numerator, meaning the top number, and the denominator, meaning the bottom number, can be written as a fraction, and where the numerator or where the denominator can never ever be 0. So they're asking which values of x will p, meaning this here, the square root of 9 over 11 minus x, be a rational number. Now guys, take these numbers and substitute them here and check which one will give you a rational number. So if you look at the square root of 9, the 9 at the top is a perfect square number. The square root of 9 at the top will give us 3, which will give us the qualification or the condition for a rational number. But now we need to have in the denominator another perfect square number. So we're looking at negative 11 and we're asking ourselves, if I substitute negative 11 in the place of x, will it give me a perfect square? All right, because when I apply the square root, when I apply it to a perfect square number, it basically will give me a integer value. Now negative 11 when substituted here is going to be 11 minus negative 11, which is 22 in the denominator. Having a 22 in the denominator does not give me a perfect square number, so therefore that cannot be rational when x is negative 11. So we leave negative 11, we move on to the next number. What about negative 5? Guys, if you substitute in the place of x negative 5, look at this. P is equal to the square root of 9 over, now you write 11 minus, is a minus already, you substitute minus 5. What happens? You have a 9 over 11, right, plus 5, because remember a negative times 11 gives us a positive, right? Then you have 9 over 16 underneath the square root. Okay, so this is a grade 10, guys. The square root of 9 at the top over the square root of 16 at the bottom will give you 3 over 4, which is a rational number. This here, guys, is a rational number. The symbol for rational number that we use is this Q. So yes, when we substitute the value of x, which is negative 5, we do get a value which is a rational number if I substitute negative 5 in the place of x. So I have to then accept that for which value of x is p going to be a rational number. When I substitute negative 11, no rational number is coming out. But when I substitute negative 5, yes, in the denominator I get positive 16, which is a perfect square number, and a square root of a perfect square number over another perfect square number gives me a rational number. What about when I substitute 0? 11 minus 0 in the denominator gives me 11. No perfect square number. What if I substitute 15? 11 minus 15 gives me negative 4. Not going to work as well, because negative numbers in the denominator, given that this is a square root, it's not going to give me a rational number. So the only value that works here is negative 5. So when you write your answer for which values of x is p a rational number, What you simply do, guys, is you say x is equal to -5. That's all. You answer 1.1.1 by simply identifying the value of x, because that's what they're asking. They're asking for which value of x is p. What is p? P is the square root of 9/11 minus x. So when I substitute x, which is -5, in the place of x, I get 11 minus -5, which is the same thing as 11 plus 5, which gives me 16 in the denominator. 9/16 underneath the square root. I take the square root of 9 at the top, gives me 3. Square root of 16 at the bottom gives me 4. 3/4 is a rational number. Why is 3/4 a rational number? Because remember, a rational number is a number that can be written as a fraction, where the numerator is an integer value and the denominator is an integer value, and the denominator can never be 0. So the value of x, which will make p be a rational number, is when x is equal to -5. So that is why I then write my answer and say 1.1.1, x is equal to -5. Let's go to 1.1.2. The next question says, for which value of x is p an irrational number? I repeat, for which values of x, so here is the list of values of x that you can choose from, is p, where is p? P is equal to the square root of 9/11 minus x. So which value of x, when I substitute here in the denominator, will give me an irrational number? What is the definition of an irrational number? An irrational number is the opposite of a rational number. This number cannot be written as a fraction where the numerator and the denominator are integers, and where the denominator cannot be 0. But when you express irrational numbers as decimal numbers, you get non-terminating and non-recurring decimals. When you express irrational numbers as decimal numbers, you get non-recurring and non-terminating decimals. So guys, when you take a -11, you substitute it here, you get 11 minus -11, which gives you 22 in the denominator. 11 minus -11 gives you 11 plus 11, which is 22. 9/22 when put under the square root. Look at the decimal that you get. Let me just take my calculator so you can see. Let's see if 11, we put 9/11 under the square root and we say equal. Then after that we press SD so that you can see the decimal that we have. Look at it. 0.90453403337. This will go on, but these are not going to be the same numbers repeating. So this is non-recurring, meaning there's no repetition, and this will be ongoing as well with other numbers featuring which do not exhibit the same pattern. So this is an irrational number because the decimals are non-recurring and non-terminating. So substituting -11 here in the denominator gives me an irrational number. When we substitute -5, we saw that we got a rational number. Substituting 0 in the denominator, what does substituting 0 do? It means I have 11 minus 0, which is 11 in the denominator. Let's check that. Okay, we had 11 in the denominator, which gives us 11 minus 0. So substituting 0 gives me 9/11. Substituting that -11 gives me 22 in the denominator. What about the decimal? It's also non-recurring and non-terminating. Why do we say non-recurring? There's no infinite repetition of numbers here. There's no pattern of repeating numbers. 2, non-terminating. It does not stop. The word terminate means to stop. So if you're saying non-terminate, it means doesn't stop, meaning the numbers after the comma, as non-repeating as they are or non-recurring as they are, they don't stop. There's other numbers after this one that are there, but your calculator doesn't have enough space to accommodate all of them. So that's what non-recurring and non-terminating actually means. So this is irrational. Okay, so that means when I substitute x is equal to negative 11, I get a irrational number. When I substitute x is equal to 0, I get a irrational number. So there are two values of x which make this p an irrational number, and those values are going to be x is equal to negative 11 and x is equal to 0. Those are the two values, right? So if you look at my mark allocation, they allocated 2 marks, and identifying those two values leads to p being an irrational number. The last question is 1.1.3, and that is which values of x lead this to become a non-real number. Guys, the word non-real means any negative number that is underneath a square root or a even root. I repeat, any negative number underneath a square root or a even root. So this here is a square root, and the moment I have a negative number underneath my root, my square root, then I can say that that particular number is non-real, which means p is non-real. So my question is, what value of x can I substitute here which will make this entire number underneath the square root become negative? Substituting negative 11, we saw it makes irrational numbers. Substituting negative 5, we saw makes a rational number. Substituting 0, we saw makes an irrational number. So that means we need to check when we substitute 15 what happens. In the denominator, if we substitute 15 in the place of x, 11 minus 15 gives us negative 4. So then the positive number 9 divided by the negative number in the denominator will give me a negative number in totality underneath the root. Therefore, that negative number underneath a square root will give me a non-real number. I repeat one more time. Substituting the x value 15 in the place of x, 11 minus 15 will give me a negative number in the denominator. That positive number divided by the negative number gives me a negative number underneath the square root. And therefore that negative number underneath the square root means that p is actually going to be a non-real number, because non-real numbers are all the numbers that underneath a square root or a even root will basically give me a non-real number. So substituting 15 specifically in the place of x does that, and it is only substituting 15. So when the x value is 15, that's when we get p becoming a non-real number. So therefore we are going to say 1.1.3 x is equal to 15. Then we are done, guys. We are done answering that question. So a question such as this, guys, a question such as this requires us to be able to have our knowledge of numbers in the number system. We need to know what a natural number is, whole number, rational number, integer, irrational number, non-real number, undefined numbers, and many other types of numbers that we have learned even in earlier grades like grade 9. We need to know those types of numbers so that when given an opportunity to actually identify other values of an unknown that will make a certain subject to become either rational, irrational, and unreal, we can easily be able to identify those values because we know our definitions. Okay, so that is how we answer the first 3 questions. Does anyone in the comment section who is in the live have any questions about 1.1.1, 1.1.2, or 1.1.3 as it refers to this question with these values that we are basically given? I'm going to give you a 10-second window period for anyone who has questions. If not, I'm going to move on and go to question 2. 10, 9, 8, 7, 6, 5, 4, 3, 2, 1, 0. Everything clear? CF, thank you so much. Really appreciate it. Let's move on to question 2. Now, grade 10s. Alright, since you are writing your March test papers that are coming up, you must then be able to, as you have learned in the term, be able to simplify expressions. You need to know how to simplify expressions. How? You need to know how to simplify expressions through expanding when the situation requires you to. You also need to know how to simplify expressions through factorization. So therefore it means you need to know how to apply the distributive law when that is required, and you also need to know how to factorize all different types of what? Of expressions, because by so doing you put yourself in a very good position to be able to score good marks when it comes to your subsequent questions. Okay, so simplify the following expressions. 2.1.1, here you can see a bracket x minus 2y, and then another bracket which basically is attached, which is 2x squared plus xy minus y squared. Now in this first bracket, what do you see? In the first bracket, you see a bracket with 2 terms, x, the minus sign, 2y. So you have a bracket of 2 terms. We call that a binomial. Okay, but because of the bracket, we know it's 1 term. Then in this bracket, you have a bracket with how many terms? 1, 2, 3 terms. So here we know that this is a trinomial bracket. But the brackets being attached to each other or being combined with each other imply what? In maths, we know that brackets mean multiply. Therefore, we are going to take the 2 terms here and we are going to apply what we call the distributive law and multiply out. After multiplying out, we are then going to identify like terms, add them, and then write our answer, and that is that. There is no factorization that is required with the product of 2 brackets. We simply simplify by applying the distributive law, then adding and subtracting like terms, and we end right there. I hope we are clear. So let us then write down that question. I hope you are doing so as well, and probably you are done even getting the answer. The important thing, guys, when you write your exams, make sure that when you have looked at the question, you must write out the question as you see it accurately on your piece of paper. Many learners forget or do not write out the questions the way that they see them. And many learners lose marks simply because they do not write the question out correctly. So make sure when you write your questions, write them out correctly. That's the first thing. 2, do not assume things. Make sure to double check that when you've written down the question, you check again to just make sure that yes, the x is still x, it does not have any additional things. The minus is still minus, 2y is still 2y, and so it goes. So that when you start multiplying out and applying the distributive law, guys, you make sure that you are clear about your multiplication. You are clear about your multiplication of 3 things. Your sign. You need to know the multiplication of signs. That a negative times a negative is positive. A positive times a positive is positive. A negative times a positive is a negative. These are important things. Multiplication of numbers. You must know very well. Okay, multiplication of letters. The application of law number 1 of exponents when you are multiplying same signs, because you must add the exponents. And then when you are also multiplying variables that are different, you just simply attach the two variables together, and that's that. Please guys, all of these things you need to know very well, so that when you do your mathematics, you do it accurately, so that you can get the maximum marks that are presented. Okay, I hope you are with me here. So here is the question written out correctly. X was there, minus 2y, I am checking, the brackets are there, 2x squared is there, plus xy is there, minus y squared is there. I make sure I'm answering the right question, grade 10s. Guys, on the screen I've written grade 10 match test example, so this is for grade 10s. Then what do? We take the first term, we distribute it to all three terms, and as we do so, we know that we multiply the signs, we multiply the number, we multiply the letter. So here, positive times a positive is positive. 1 times 2 is 2, that's the number. X times x squared, we keep the variable, we add the exponents, we know there's an invisible 1 plus 2, which is to the power 3. We've just successfully multiplied our first terms in each bracket, and it's 100% correct. What a wonderful feeling. You take x, you multiply it with positive xy. Positive times a positive, give positive. Now you go on to the number. 1 times 1, give 1. X times x, give x squared. And then the y, you just attach next door. What a good feeling to have multiplied the second terms and basically 100% correct. We take the x, we multiply with negative y squared. Positive times a negative is negative. 1 times 1, which we cannot see, is 1. X times y squared, we glue them together. We have just completed distributing x to all three terms in this bracket, and everything is going so great. We take negative 2y, we distribute it to 2x squared. Guys, please take note, this is a negative 2y. It's being distributed to a positive 2x squared. So you say a negative times a positive, be negative. 2 times 2 is 4. Y times x squared is x squared y. It is the x squared that is squared and the y attached next door. I just write these in alphabetical order. X is followed by y, just to make things easy for myself. We take negative 2y, we distribute to the next term. Negative times a positive, negative. 2 times 1, give 2. The one that we don't see, which is invisible, like the Holy Spirit is always there, ever present, doesn't get credit, but is there. Then xy times xy. Guys, there's x, then the y times y, which is y squared. Last but not least, grade 10s, you take the negative 2y, you distribute it to the last term. Negative times a negative is positive. 2 times 1 that you don't see, that is 2. Y times y squared, this is y to the power. Remember, the exponent for y is 1. Plus 2, that gives you the exponent 3. All of my terms have been accounted for. When I distributed this to 3 and distributed this to 3 terms, in total I should have how many terms? 6, guys. 1, 2, 3, 4, 5, 6, and they are accurate. Now all I do now is I look for like terms. Like terms are terms that have the same variable and exponent. Like terms have the same variable and exponent. So 2x cubed is alone, does not have a like mate. X squared y has a like mate that is negative 4x squared y. So when we are adding these two together, we keep the x squared y, which is the uniform of the school. X squared y and x squared y will not change when we're adding them. But what will change? There's a 1 that we don't see, minus 4. 1 minus 4 is negative 3. We are done with these two like terms. We then turn our attention to xy squared. It has a like term, which is xy squared, which is negative 2. So we take negative xy squared minus 2xy squared. We keep the uniform xy squared as it is, and then we say what? What's negative 1 minus 2? It is negative 3. All right. Then last but not least, our last term, which is positive 2y cubed, we just write that term because it has no mate. Then we look at our terms and we are like, well, is there anything more that we can add and subtract? These are not like terms. Though they look like they are, this is x squared, this is x. The exponents are not the same. This is y, this is y squared. The exponents are not the same. These are unlike terms. We keep unlike terms, not do anything else. We are done with simplifying this multiplication of these two terms with the multiplication of these three terms. We are done. Okay? Full marks. Move on to the next question. 2.1.3. Simplify the following expressions. X squared minus x plus 1 over x cubed plus 1 divided by 2 over x squared minus 1. So you will look at this question once again. No, Amma. You see, Amma, you were not listening when I was explaining in the beginning. You were not listening when I was explaining at the beginning. When we say simplify the following expressions, we are looking at 2.1.1, and what is it saying? We must simplify this. Simplifying this, what do you have before your face? This is a x minus 2y. Brackets in maths mean what? Multiply. So it's like you are multiplying two things, a binomial with a trinomial. So guys, when you are multiplying out, this simply means to you, it means you are going to apply the distributive law. That's the first thing that must come to your mind. 2, after applying the distributive law, that's going to lead to a removal of the brackets, as you saw in the problem. Then you are going to add and subtract like terms, and then you will leave your answer as that. There's no need for factorization. Why? Because this is simply saying that we need to simplify, and it's a product of two things. So basically, a product of two things means that we have simplified completely when we are here at this stage. Nothing more can be done. You stop right there. That's it. Okay? Remember, this is like if I was given 3 times 8. If they are saying 3 times 8 to you, what's 3 times 8? It's 24. Right? Because it's a product of two numbers. Simplifying 3 times 8 means getting the answer 24. Alright? So please guys, let's be very clear. The question must explicitly say factorize in order for you to go ahead and factorize where there's a product of two things. So please, let's be clear about that. Now look at this question. This question says simplify the following expression, and what do you see? You see two fractions, a fraction with 3 terms in the numerator and 2 terms in the denominator. Why do we say there are 3 terms in the numerator? Because the terms are separated by a minus and a plus sign. Then why do we say 2 terms in the denominator? It's because we've got x cubed plus 1. There's a division sign there, and then there's 2 over x squared minus 1. So we are dividing two fractions. And basically, what does that then mean? There is a procedure and a process when we are dividing two fractions, especially if it has algebraic expressions, meaning the terms actually contain variables in them as well. So what we do is first step, we look at the numerator and the denominator. And then when we have looked at the numerator and the denominator, we look at and we decide as to whether can factorization be applied in the numerator and the denominator of each respective fraction. Where there's a division sign, we apply the KCF rule. What does KCF stand for? It means you keep the first fraction, you change the sign, you flip the second fraction. So let's write out this question first and then we can go ahead and attempt it. X squared minus x plus 1 over x cubed plus 1 divided by 2 over x squared minus 1. So first and foremost, because we have division, let's play around and apply KCF. K means keep. What are we keeping? The fraction that is the first one as it is. We keep this as it is. C means change. What are we changing? We are changing divide to multiply. F means flip, or we mean invert. The 2 over x squared minus 1, we write x squared minus 1 over 2. This is basically what I mean by KCF. We always apply KCF when there's division between two fractions. We change the division to multiply so that simplification can happen seamlessly. Oh my goodness. Can you hear the English? Simplification can happen seamlessly. After doing or applying KCF, we are now going to look at the numerator, denominator, and we factorize if possible. Factorize if possible, not just for the sake of factor. If possible, we factorize as we look at numerator and the denominator. We do this, guys, when we have multiplication and division of fractions purely. Okay, please, guys, this is a procedure we can follow. You know, just like doctors have a procedure when they are doing operations or doing certain things. This is you in the foundational stages in high school learning certain different procedures so that you can get into a procedural state and a methodical state so that you can be someone who understands procedures and processes. So there's a procedure. Like I said, we are dividing two fractions. They are algebraic in nature. They are terms that we can count at top and bottom, numerator and denominator, terms that we can count top and bottom. We look at this and can we ask ourselves, can we factorize this? And the answer is no. I know some people who will look at this and be like, hey, let's open two brackets. Guys, can I just give you a word of advice? Yes, this is a quadratic expression. There's an x squared at the beginning. But guys, opening brackets happens when you are very clear that, okay, the factors of 1 are present that I can multiply, which can give me 1. And when I add them, give me -1. There are no such factors, guys, that exist which you can multiply and they'll give you 1, but at the same time when you add them they give you -1 as a coefficient. So that's why we dare not rush to open brackets when an expression that is quadratic is obviously unable to be factorized. Do you know why I'm saying that even more? It's because whenever you factorize a trinomial that is quadratic and the last term is positive, you usually open two brackets that have the same sign because of the positive number that is the last term. Positive number as the last term means you are going to have same signs when you open your two brackets. But those same signs are going to be the same according to the sign of the middle term. So the factors of 1 are 1 and 1. When you would make 1 and 1 the same, you are going to get -1 and -1. Adding -1 and -1 does not give you -1, but rather it gives you -2. So that is why factorizing this is not feasible. It is not possible. So I'm simply going to write brackets around x squared minus x plus 1 to just show that there's a 1 that I've taken out as the highest common factor, which is the only thing you can do, so that the three terms I have can now be represented as being 1. Brackets make it 1 term instead of 3 terms. We go down to x cubed plus 1. When you look at x cubed plus 1, what do you see? Let's see in the comment section if we've got true maths students in the mix. X cubed plus 1, remember I said look at the denominator and the numerator, check if you can factorize. If you look at this, what is this? X cubed plus 1. what type of factorization can be applied? I'm going to just remove this heading that says grade 10 mathematics test, March test example. Hope you guys don't mind. I'm going to remove this. Okay, Melo is saying it's a binomial by a trinomial. That we definitely, Melo, we are going to factorize. We are going to get a binomial by a trinomial. Melo, I'm so proud of you. Okay, so cubic factorization, this is the sum of two cubes. So what do? You open a binomial by a trinomial bracket. Melo is like spot on. Since this is the sum of two cubes, let's first sort out the signs inside the bracket. I usually keep write S for signs. Okay, remember the movies, S and L, but signs, the S stands for that. So since we have a positive, that means our first bracket is going to be positive. Then as always, we follow it up with a negative, positive. That is going to be the state of my terms inside the trinomial bracket, negative, positive. So since this is positive, I write my first bracket as positive. Then I follow it with negative, positive. What if it was negative, guys? It was a difference of two cubes. Then I would write this bracket as negative. Then I would follow it up with positive, positive. That is always the case, guys. Standard. But you do that when you have a sum or a difference of two cubes. Why do we know that x cubed is a perfect cube? It's because any variable that is raised to a exponent, which if you divide that exponent by 3, you get an integer value. That means that's a perfect cube. 1 is a perfect cube because 1 times 1 times 1 gives you 1. 2 times 2 times 2 gives you 8. So if we had 8 as well, we'd say it's a perfect cube. 3 times 3 times 3 gives you 27. So if we had 27 as well, we'd say it's a perfect cube. 4 times 4 times 4 gives you 64. So if we had 64 here, we know it's also a perfect cube. 5 times 5 times 5 gives us 125. So we had 125, we know it's a perfect cube. 6 times 6 times 6 gives us 216. So if we had 216 here, we know it's a perfect cube. So I hope you guys get the point. All right, now let's find out what are the numbers inside the brackets. So we go here, we take the cube root, guys, the numbers and the letters that are here, you take the cube root of x cubed, cube root. All right, by taking the cube root, you're saying x to the power, this 3 that you see here is in the numerator of the rational exponent. Then when you remove the cube root, you divide this 3 by this 3 and you get what? X to the power 1. So that means here I can put x to in the place x cubed, you write x because the cube root of x cubed is x. Then you ask, what's the cube root of 1? Cube root of 1 is also 1. Then you write 1 here. Okay, I hope so far we understand what's happening here. To get the first term in this bracket, you square this term. When you square this term, you get x squared. When you square the last term, you get the last term in the other bracket, it's 1. So you square this term, you get that. You square this term, you get that 1. Then to get this middle term, guys, all you do is you take the product of these two terms that you found after cube rooting it. The product of x and 1 is simply x. You ignore the sign, you just take x and 1, you multiply them, you get x, and that is your middle term. Now I'm sure you can see, you see this one. Hey, here is the guy who's going to cancel him. So that's why this guy was not factorizable, because there was a guy who was going to come and cancel him. They were going to come and cancel each other. How nice. Okay, let's come here now to x squared minus 1. Hopefully cubic factorization is understood, my good people. Are we flowing together? Can I just get an amen in the comment section? Maybe someone to just sort of like rose me up a little bit there, to kind of say, yes, we are with you, I hear you, we are still listening. Just a few things there and there, or simply saying amen with the answer there. Melo is yesing it up there. Okay, all right, I see. Yeah, Melo, you are really here. When Asham, you are here. Okay, so sum of two cubes, guys. This is how we do it. Difference of two squares. You can see here, this is x squared minus 1 difference. X squared, perfect square. Any variable raised to an even exponent is a perfect square. 1 is a perfect square. So what do we do here? Me and you open the brackets. Very simply. Take care of the signs first. We write a plus and a minus sign. We know that when there's a minus sign for our last term, it means different signs inside the bracket. Then we will do what? This time we don't use the cube root because these are not perfect cubes. These are perfect squares. So this time round we are going to take the square root. The inverse of a square is square root. So the square root of x squared, key x and x, as Ruben has said in the comment section, the square root of 1 is 1 and 1. And that's done. All over 2. Now we can play. After factorizing, step number 3, we cancel top to bottom. No, not top to top, but we cancel top to bottom. And we do so, guys, literally once. All right. So this and that we cancel once. We are left with 1 and 1, literally, because something divided by itself gives us 1. This and that one, because it's x plus 1, x plus 1. You see, so it's in this fraction in the denominator, this fraction, which is a different fraction in the numerator, top and bottom. That's why I'm saying you cancel top and bottom ones. You are left here with 1 because this divided by itself is 1. So at the top now, what do we have? 1 times x minus 1. So here now at the top, we are left with x minus 1 over what? 1 times 2, we are left with 2. So that's what we are left with there. So you could actually write down your answer as x minus 1 over 2. We do not cancel across an addition and a subtraction sign. So let's say you had a 2 here, you would not be able to cancel the 2 and the 2 because we don't cancel, guys, across an addition and a subtraction sign. We only cancel when things have a product. Okay. Simply answer okay, that's fine, but that's just so that it's just for you to know, because answer the danger in not knowing that there's a 1 left if things are the same. Say for instance you had x plus 1 over x plus 1 to the power 2, right? Let's say this was what was left. You would cancel, right, the x plus 1 and the x plus 1. But remember, how many x plus 1s were here? There were 2 of them, 2 x plus 1s. So that means you will be left with 1 of them here in the denominator. But then in the numerator, remember, when you cancel that x plus 1, all of it at the top, you are left with just 1, the number. So this becomes 1 over x plus 1 as your final answer. So when we omit to actually acknowledge that it's not like things disappear and there's nothing. No, when you cancel to disappearance, remember there is a number 1 that is left behind for that which you think is disappearing. So hence we need to acknowledge that one. In many instances, it's going to save us so that we write the correct answer. A person who does not acknowledge that one may well write his final answer as being x plus 1 without having the 1 at the top, and then they lose marks. So that's why the emphasis on the 1. Okay, 3 divided by 3 is 1, right? It's like saying something divided by itself is 1. But remember, the 3 and the 3 have a highest common factor, which is 3. 3 goes into 3 once. 3 goes into 3 once. So 1 over 1, is 1. So I hope you understand the case. So here, because this and that are similar, you divide something by itself, it leaves 1. Okay? So it's like 1 over 1, which is actually 1. You divide this with itself. That's why we cancel top and bottom, because it's like we're dividing something with itself. We get 1 and 1. Yeah, I hope you understand. I hope that is clear. We need to be clear about these things because they are important. Yeah. All right. So just clarity. Okay. 3.1. 3.1. Simplify the following. Now we are having exponents that we are needing to simplify. 5 to the power x plus 0 plus 5x to the power 0. Okay, you guys can do this one and then tell me in the comment section. It is 1 mark. What do you get? Your answer there in the comment section. Okay, so 5x to the power 0, 5, the x to the power 0, any base raised to the power 0 is 1, plus 5x everything to the power 0, every base is raised to the power 0, so the entire thing is 1. So we have 5 times 1, which is 5, plus 1, which is 6. So that's straightforward, guys. Not too much thought. We check the 0 is applied to x, so it's only x that's going to be 1. But here the 0 is applied to everything inside the bracket, so this whole thing is raised to the power 0. So when you apply it to that, we get 1. 5 times 1 is 5, plus 1 basically gives you 6, and that's that. Let's look at the next question, guys. Not waste too much time. Okay. Yes, Noni, very good. Very good, Noni. Proud of you there in the comment section. 8 times 3 to the power negative n over 3 to the power negative n plus 2 minus 3 to the power negative n. So what we have here, guys, is basically a multiplication of exponents in the numerator, but at the denominator we have subtraction. Now immediately when I see multiplication, I'm very chilled with multiplication. Okay, but the minute I see addition and subtraction, I think of factorization. Okay, so we basically are going to first split or expand 3 to the power n negative n times 3 to the power 2. We split 3 to the power negative n plus 2 to become 3 to the power negative n times 3 to the power 2. Why are we doing that? Because there's subtraction in between the bases. Minus 3 to the power negative n. Because we are thinking of split and immediately factorize where the denominator is concerned. What type of factorization? Taking out a common factor. So here, this first term, this second term, we can see that there's a common factor of who. So for now, we leave that multiplication in the numerator. Then we take out 3 to the power negative n in the denominator, leaving us with what? 3 to the power 2 on the left minus what? 3 to the power negative n times what gives me back 3 to the power negative n. What do I write here after the negative? Okay, and do we acknowledge, guys, that when we take out 3 to the power negative n for the left, we're left with 3 to the power 2. But taking out 3 to the power negative n for the right, okay, after the negative sign, leaves me with very good Mabungi Mazibuko. Beautiful. Zanela Chenge, good. Tamikulu, amazing. 1. We close the bracket. Are we together? Then, guys, we have a product of 8 and 3 to the power negative n. Here at the bottom, we have the product of 3 to the power negative n with what is inside here in brackets. cancellation is possible. Why? Because this guy and that guy, the 8 is multiplied to 3 to the power negative n. The 3 to the power negative n is multiplied with what is in here. So cancellation is possible where the relationship between what is in the denominator and numerator is multiplication. By the way, we have one term at the top, one term at the bottom, even that much more. The 3 to the power negative n is outside, and this 3 to the power negative n is multiplied to 8. So cancellation can happen seamlessly. What are we left with in the numerator now? Remember, I said we are left there in the place of what we've cancelled, 1 and 1. 8 times 1 in the numerator is simply 8 over. At the denominator, we have 1 times whatever is in brackets. That is 9 minus 1, which is what? 9 minus 1 is 8. What's 8 over 8? It gives us 1. Simple, guys. All right. So when we have a plus and a minus sign between our exponential bases that are numerical in nature, we always look at the types of factorization that can be applied. We can have a situation where it's difference of 2 squares. It's possible. We can have a situation where it's trinomial quadratic. All right. And please let us not forget about the different types of factorization, even as they operate in exponential expressions. Very possible for us to have those manifest in the numerator and the denominator. So let's remember that when you have a plus and a minus sign between the exponential numerical values, please. Okay, very important. Let us proceed. I think we have answered that question nicely. We now have equations coming up, right? The first one, very nice and cute. Okay, solve for x. 2 to the power x plus 2 is equal to 8. Aye, very nice, that one, very beautiful. Okay, this one is even can be done by a grade 8 learner, and even a grade 9 learner can do it. And then when you are in grade 10, when you should be able to do it sleeping in your bed, you know. And all the other grades, they should be able to answer this one very nicely. Okay, so that's very important. 2 to the power x plus 2 is equal to 8. So objective of exponential equations is to make the bases the same on either side of the equal sign eventually, so that answers can be found. All right, so here base 2 is prime on the left. 8 can be changed to base 2 as well. So 8 can be converted to become what? Yes, Anela Chenge. When you have same bases, then you can basically say you drop them or they fall away, and then you equate the exponents. So here 2 to the power x plus 2 is equal to 8. We are fine on the left. On the right, we just need to have 2 to the power 3 written in the place of 8. Remember, our calculator is always there for us. When we don't know, we can always type in the number that is concerned, press equal, press shift, press fact. Voila, the calculator gives you 2 to the power 3. Bases are the same. Drop the base, equate the exponents, transpose. We have a linear equation now. We just transpose the 2 becomes negative 2. Our x value is equal to 1. Very nice, that one. Very true. Even dash is dashing away. Okay. Let us continue. Question 4 seems even nicer. Okay. 4.1.1. Very nice. Very nice. Linear equation. Grade 8 can even do this one. But when you are being asked such a question, 15 minus 3x is equal to 2x minus 25. Dash is like my favorites. Yeah, hopefully you are in grade 10 and you are in the appropriate grade to say they are your favorites. You are not in varsity and you are wishing for those good old days when you are doing such questions. Okay, yeah. Guys, please, I really would appreciate it. We are currently having a Bandiscover roses. If you can support the live creator with your roses and also your awesomes, you'd be really welcome, guys, if it's possible. Yeah, we welcome such. Okay. 15 minus 3x is equal to 2x minus 25. Guys, whenever an equation is obviously linear, x has an exponent 1. 2x, the variable, has the exponent 1. That's linear. So we isolate. What do we isolate? We isolate the variables on the left, and then we isolate the numbers on your right. You see, when 2x goes over, change the sign. When 15 goes over, negative 15. Then we have negative 5x is equal to negative 40. Okay, when we want to solve for x, we divide by what here? By a negative 5. What we do on the left, we do on the right. X is equal to 8. Finished. Yeah, very straightforward, that one. It's like a snack. It's like a nice snack. Let's look at the next question. Question 4.1.2 is a topic that is referred to as inequalities. Inequalities. What is the objective? Because we refer to this kind of inequality as a compound inequalities, it has three parts. It has a minimum, it has the restrictive variable, and then it has a maximum. Minimum, restrictive x variable, maximum. So your smallest value, then your variable, and then your maximum value. So the objective then is that here in the middle, we want to isolate x. We want x to be alone. But who's interfering? Negative 7 is in the way. Okay, it is interfering. It needs to go. Positive 2 is in the way. It is multiplied to x. It needs to go. So how do we get rid of negative 7? We apply the additive inverse, or we can say we transpose negative 7. But we don't transpose it just to the maximum. We also transpose it to the minimum. And then it disappears here in the middle, right? We are left with 2x. How do we get rid of the 2 that's multiplied to x? Obviously, then we would apply the multiplicative inverse, divide by 2. But we don't only divide here in the middle, we divide in the minimum, we divide in the maximum. Then that way x is isolated and we get the inequality and the actual values that satisfy the inequality. So let's go and look at this question more specifically. I said we need to isolate x in the middle. So the first thing, transpose the negative 7, but we don't transpose it to one side. We transpose it here, then we are left with 2x. We transpose it there. Alright? So I hope we understand the transposing part first. Remember guys, the word transpose is simply a concept being applied, which is an underlying concept called the additive inverse. Remember, the additive inverse of minus 7 is plus 7. That's how you get rid of this negative 7. You say negative 7 plus 7, then 0 basically is the result. We're left with 2x alone. But when you add by 7 here, you must add by 7 there, you must add by 7 there. That's why you see this idea of we transposed. But the underlying concept of transposing is the additive inverse. What is the additive inverse of negative 7? It's plus 7. That's why you add 7 everywhere, including here in the middle. Then what do you get? 4, 2x, and the 14. Next step, this is a positive 2 that you have here, coefficient of x. You divide by the 2. But what you do there, you must do everywhere. Okay? Dividing by 2. Alright. Guys, if this coefficient was negative, then we would have changed the direction or reversed the direction of our inequality signs whilst dividing by that negative coefficient. But because here we have a positive, the signs don't have to reverse, but they would reverse if, let's say, it was negative 2x and we are dividing by negative 2. Okay? We get 2 we get x, we get 7, and that's it. Okay. Sometimes they ask you to write this answer. This question did not do that. But sometimes they ask you to write the answer in and represent your answer on a number line. Okay, when you are asked to do that, you would write the 2, 7, you shade the dots where the 2 and the 7 are. Why are you shading them? It's because the equal sign means this value of x lies between 2 and 7, but you include the 2 as well. It's part of the answer, so that's why we shade where the 2 is. We include the 7, that's why we shade at 7. So every other value in between 2 and 7 is also part of the answer that will satisfy. It falls in the category of values of x. If I substitute here, you are going to see that whatever value you get here is going to be bigger than or equal to -3, but smaller than or equal to 7. Okay, so it's very important that. Or sometimes, so this is a number line, just in case in a question they say represent your answer on a number line. Okay, if there was no equal sign, guys, let's say there was no equal sign, let's say it was 2 less than x less than equal to 7, you would still do this, but then this would have an open dot this time. Why open? Because there's no equal sign. 2 is not included, so you only include and shade, but if it's not included, you open the dot. So it would be open, but then for 7 it would be shaded, so it's 2, 7, like that. Okay, let's say the answer was one where you were solving an linear inequality like this, and then you transpose and you get x is greater than or equal to -3. In a number line, guys, what you would do is you would actually say shade x values where you have greater than or equal to 3. So you include the 3, but then greater than is an arrow this side. All values this side of 3 are greater than 3. Okay, so take note of what I mean in the by number line. Interval notation is also another notation where they say you should use. So shaded dot equates to square brackets. Open dots equate to open brackets. So if you were to write an answer here, we would say between 2 and 7, where 2 is included and where 7 is included. That's from 2 to 7. Okay, here you would write, for cause an open dot, you'd say open brackets to shaded dot, because that's a shaded dot, you're including this, and it's 2 to 7. Okay, we call this interval notation. Okay, here 3 shaded to what? To infinity, open. Guys, infinity is not in a finite number. It's a number that it is a concept that denotes numbers going on forever. Okay, I just wanted to add some explanation there so that you are clear about inequalities and you are not misinterpreting the inequalities. Right? Okay, let's move on to the next question. 4.1.3, x plus 5 into 2x minus 8 is equal to 0. X plus 5 into 2x minus 8 is equal to 0. So here we have a typical, already here we are like at the factorized stage. 2 brackets equal to 0. So what would you do here? You take that first bracket, x plus 5, you make it equal to 0, or you take that second bracket, 2x minus 8, you make it equal to 0. What are you doing there? You are applying a rule called the zero factor law. 2 factors equal to 0. So 0 factor law. You take x plus 5, you make it equal to 0, or you take 2x minus 8, you make it equal to 0, and then you solve those linear equations. Okay, like this. x plus 5 is equal to 0, 2x minus 8 is equal to 0. You take the 5, you transpose it, x is equal to negative 5. Or 2x, you take the negative 8, you transpose it, you have 8, divide both sides by 2, you get x is equal to 4. That's really straightforward, guys. Simple. That was the answer. No problem. Okay, no problem. Like, so straightforward. Megamind LI. Of course I have WhatsApp. What do you mean, do I have WhatsApp? Of course I have WhatsApp. But the thing is, unfortunately, like, if you're talking about how did you just join in the live haphazardly? Mega, are you in grade? What grade are you in? Are you in grade 10? What grade are you in? Why are you asking about WhatsApp group? Let's clean that there. Let's look at 4.2. Given that 3x is equal to 12, guys. Okay, another nice exam question. Control test for March. 2x plus y is equal to 2, and they are saying determine the value of x minus y, the whole thing squared. Given that 3x is equal to 12, 2x plus y is equal to 2, determine the value of x minus y, the whole thing squared. So here we have equation 1 and we have equation 2, but through those two equations we need to then be able to determine the value of x minus y, the whole thing squared. So in other words, from these two equations we should find x and y. After finding that x and y, we need to then substitute it directly into this expression so that we can get the actual value of this expression when those x values and that y value are there. So let's take 3x is equal to 12 and make x the subject. How? Divide both sides by 3, x is equal to 4. Okay, so x is equal to 4 is our value that we're going to substitute of x there. We take that x is equal to 4, substitute x is equal to 4 into equation. Which equation? The one we have not touched, which is equation 2. Take x that you got, which is 4, substitute it into the other equation, the one that we did not touch. I repeat, take x is equal to 4, substitute it into the other equation, equation 2, which you did not touch. Go there, write that equation, equation 2, and then x follows. In the place of x, we are going to substitute 4. So that 2, the x has been substituted with 4. You follow it with what? With plus. You follow it with what? With y. You follow it with what? With equal to 2. Okay, so you took equation 1, 3x is equal to 12. Of course, the coefficient of x is 3. We divide by 3 both sides, we get x is equal to 4. Take the x is equal to 4, go and substitute it into equation 4, in equation 2. So that means the x in the place of x, where x is in this equation, you are going to substitute who? 4. So we write this equation 2. Then in the place of x in brackets, we put 4. Guys, when you substitute, put your values in brackets. Put your values in brackets. Plus what? Plus y. Plus y is equal to 2. There we have it. So 2 times 4 is 8, plus y is equal to 2. You isolate y. You take the 8 over. Negative 8. Y is equal to negative 6. So remember, we have x now, which is 4, and y, which is negative 6. And the question will say, determine the value of x minus y, in brackets, the whole thing squared. So let's go and write the x minus y, the whole thing squared. Remember, we have x, which is 4. So in the place of x, I'm going to write 4 in the place of x. There's a minus sign already here. The value of y is in brackets minus 6. Let's square it. Then let's simplify this. 4 minus 6 is 4 plus 6. 4 plus 6 is 10. You square it, you get 100. So the value of x minus y, the whole thing squared, guys. In the place of x, I substituted 4. There it is. In the place of y, I substituted negative 6. There it is. Also, not forgetting that there was already a negative sign, which is why a negative times a negative gives me a positive 6. Then 4 plus 6 gives me 10. And 10 squared gives me what? 100. Thank you, Fan. Fan, you always, hey, Fan, when you come through, my fan friend, you always are able to at least liven up the live. Thank you so much. I really appreciate it. I wish more of people that are actually in the live lesson could actually just, yeah, man, guys, it doesn't matter, even if it's tapping, because the funny thing is that some people are just here. Even if it's tapping, guys, maybe someone who is generous will come through and gift. Maybe it won't be you because you are not in the position, but tapping on the screen, guys, gets the live visibility out there. And then random people can come through, and sometimes it's when random people that have a heart and basically are just like, this guy's doing something, then they can gift. And trust me, guys, I need those gifts. Trust me, I need those gifts. Jo. Thank you, though. So now that question is answered. Okay, very well answered. We answered that question very nicely. Okay, nice question. A bit different, departs from normal, but it does the things. Now we're going to answer 4.3 and 4.4, and that should be it, guys. Yeah, we should be able to be done before 12. Given E is equal to half mv squared plus mgh, make V the subject of the formula. So guys, we are now looking at a question that involves a section of the maths in grade 10, which we call literal equations. We are now smack bang in the midst of a section of the work which we call literal equations. Literal equations is a very important topic, because as a math student who may probably be doing physics, you will be exposed to formulas which you will need to use to calculate certain unknown variables. But you need to be in the place where you can manipulate a formula and solve for a particular variable that is not the subject at that moment. So for instance, if you look at E is equal to half mv squared plus mgh, this is a formula you use in physics. Okay, yeah, it's a formula you guys use in physics. It's a formula you use in physics, whether in grade 10, 11 or 12 is basically what you will find out, but it's used in physics. Now sometimes you will be required to calculate E, sometimes you'll be required to calculate the M, sometimes you'll be required to calculate V. So you need to be able to manipulate this formula so that you can get the subject of the formula to be what you want. So the question is saying E is equal to that, make V. So we need to make this guy V the subject of the formula. So let's write it. E is equal to half mv squared plus mgh. Guys, all you do here is you are using your skills of what? Transpose is used here. In other words, your additive inverse. Okay, that idea of a term, you can actually make it cross over and it changes sign. Your multiplicative inverse is used here. The idea that when you have a coefficient of something, you can divide by it, or when you have a denominator and you want to get rid of it, you can multiply in the numerator by that denominator to eliminate it. That is what we call the multiplicative inverse. We use that a lot in literal equations. You need to know that the inverse of a square, for instance, is a square root. because sometimes you will be required to get rid of a square, by applying the square root, or get rid of the square root by applying a square. So these are things that are important, right? And an inverse of a square is a square root. The inverse of a square root is a square. So you need to be able to know that if you apply the square root on one side, then you must apply it on the other side of the equation. What you do on the left, you do on the right with the equations. Then, yeah, you'll see, guys. You'll see. So what do we want? We want V to be the subject. In other words, we need to isolate V. Who is in the way of us isolating V? First and foremost, on the left, we have how many terms, guys? This is very modern. Okay, on the left, how many terms do we have? We want V to the subject, but already we are like looking at the left and we're like, in order to isolate V, okay, how many terms do we see? This is 1, this is 2. So that means this is added to this as MGH. Let's move MGH so that it's not there, because we are on our way to isolating V. So we can take MGH and say E minus MGH is equal to half MV squared. So I could say we are close now. We are very close. We've taken MGH over. So basically we've applied transposing because our objective is to isolate V. Then what else can we do? We can get rid of half MV. We can get rid of M, not half MV. We can get rid of half M because we want V isolated. So what do we do? To get rid of this half, okay, you can multiply by 2 in the numerator. So that means if you multiply by 2 on the right, then you need to multiply by 2. But remember, when you multiply by 2, you're multiplying by 2 for everything, right? So multiplying by 2 here cancels the 2 and the 2. And we are left with mv squared, 2 into E minus mgh so far. Now we need to get rid of what? Of m. So what do we do to get rid of m? M is like the coefficient. So we are going to divide both sides by what? By m. What happens inside? We cancel and cancel. We're left with v squared. 2 into E minus mgh over m. Want to get rid of the square. So once again, remember what I said earlier on, the inverse of a square is your square root. So we are going to take the square root on the left, but what you do on one side, you do on the other. When we apply the square root to the square, here we know we are left with v alone. Then on the other side, we have the square root of 2. You can distribute if you want that 2 into the E and into the mgh. It's really up to you. Okay, in actual fact, let's advise that you do all over m. Then we know that the equation where v is the subject is simplified very well. So guys, literal equations are helpful because this is the way in which we can be able to make something the subject of an equation. All right, it's a useful technique which helps us out a lot in so many areas, especially if you're doing physics and you're doing other topics. Literal equations are so important. There are many formulas in physics, but using this approach where you can isolate one term and write v in terms of E, M, G, H, and M. It's like you've written v in terms of E, M, G, H, and M. Okay. Solve for x in terms of something else. That means in that particular thing, when you have that subject, solve for x in terms of something else. Say for instance, solve for x in terms of p. That means you are going to have x as the subject and you are going to have some p values on your other side of the equal sign. Okay, let's finish off, guys. Do the last question. Thank you, Fan. Oh my goodness, Fan, thank you so much for the finger. I'd really appreciate it. Yo, Fan is very generous tonight. Thank you, and thank you. Thank you. I appreciate it so much. Thank you. Thank you. Thank you. Ke a leboga. 4.4. Just want to expose you because in grade 10 we also do word problems, okay? And we need to be people that are well versed in word problems too. You know, word problems, we need to apply algebraic means to do word problems. So let's look at this. Khetang saves 1 rand. Okay, 1 rand and 2 rand coins. Okay, in his money box. To do what? To buy 60 rand data bundles. He counted 34 coins after opening his money box. Counted how many coins? 34. After what? After opening his money box. The question is, how many 1 rand coins were in his box? Okay. Khetang saves 1 rand and 2 rand coins in his money box to buy 60 rand data bundles. He counted 34 coins after opening his box. How many 1 rand coins were in his money box? So this is a nice question, guys. Okay. So here we are going to assign some variables. We are going to let x be your 1 rand, the number of 1 rand coins. Okay, because the question is saying how many 1 rand coins were in his money box. So you let x be the number of 1 rand coins, and we're going to let y be the number of 2 rand coins. Okay. Let x and y, let x be the number of 1 rand coins, let y be the number of 2 rand coins. So Khetang saves 1 rand and 2 coins, or 2 rand coins in his money box to buy 60 rand data bundles. 1 rand and 2 rand coins. So we can say x plus y is equal to 60 rand, because he's going to use the money to buy 60 data rand bundles. So it says he counted 34 coins after opening his money box. How many coins did he count? 34. So what do you guys think? If you counted 34, what means that? What does it mean? What do you guys think? Okay. So he's going to buy 60 rand data bundles with these coins, 1 rand and 2 rand coins, but at the same time he counts a total of 34 coins. So we also know that, so we know 2 things about these coins. That is, first and foremost, he's going to buy with these coins 60 rand data bundle. And then we also know that in total there are 34 coins, right? So now what we want to know is, what is the number of 1 rand coins? That's what we want to know. So now let us proceed and actually solve these two equations simultaneously. So we've set up two equations on the basis of the information that we're given. We were told that he wants to save 1 rand coins, and we were told he wants to save 2 rand coins. These are separate coins, all right? So we assign different variables for the coins. We let X be the number of 1 rand coins, and we let Y be the number of 2 rand coins. Okay. Then we were told additional information, and that is he wants to buy 60 rand data bundles, with these coins. Okay, so that is the total number of those coins. He wants to buy 60 rand data bundles. But also we know that he has 34 coins in total. Okay, we don't know how many are 1 rand, and we don't know how many are 2 rand, but we know that he has 34 coins in total. So that's basically why we say X plus Y is equal to 34, because the sum total is 34. The sum total of the number of coins that he has, he's going to actually go ahead and buy 60 rand data bundles. So now let's solve for X and Y. Remember, when we solve, we take one of the equations, we make X or Y the subject of the formula, and then we refer that to equation 3. Now we are going to substitute what? Equation 3 into equation, the one that's not touched, equation 2. So in the place of X in this equation, we are going to substitute 60 minus Y in brackets. So let's go 60 minus Y. So in the place of X, we've just substituted 60 minus Y. What does it follow? Y, which is equal to what? 34. What's happening here? Wait, I misread something here. Just a sec. I just want to check if I didn't misread the information in the question. Sorry guys, just want to check this out. What did I say here? Khatang saves 1 rand in his money box to buy data bundles. He's counted 34 coins after opening. How many coins were in his money box? Just read. Just want to check if I didn't. I think the wording, I missed something in the wording. Oh, I was supposed to say, because it's 2 rand. Oh, X plus 2Y. No, that's fine. X plus Y, X plus 2Y. So X plus 2Y is equal to 60. So I'm supposed to say 60 minus 2Y. Alright, I was wondering why that's the case. X plus 2Y is equal to 60. So that is 60 minus 2Y. 60 minus 2Y plus Y is equal to 34. So let's solve. So that's negative 60 minus 2Y plus Y is equal to 34. We take the 60 over, we get negative Y is equal to 34 minus 60. Right? And our 34 minus 60, that gives us negative 26. We divide both sides by negative 1. We get Y is equal to 26. And after doing that, it means we can go now, because remember, we want to know what is the number of 1 rand coins. All we want to know is what is the number of 1 rand coins. So we can go ahead now and actually go and say we're going to substitute Y is equal to 26 into what? Well, we can substitute in any of the equations, but specifically here x is weighting. We can substitute the value of y in the place of x. We'll say x is equal to 60 minus 2 into 26. We get 60 minus 52. X is equal to 8. Therefore, remember, what did I say x stands for? It's the number of 1 rand coins. So that means there are 8. Therefore, there are 8 1 rand coins. And that ends that story. Okay. Yeah, so that's finished now. Yes, immediately after the time, just before the time that was allotted, which was basically before 12, as I had planned. Okay guys, so that was just one of the revision sessions for today for grade 10. I hope you guys grabbed a thing or two there. Yeah, word problems are definitely going to be featuring, or let me tell you this one thing. That was one of the things last year, in last year's paper for grade 12s, that really caught the grade 12s, was the fact that simultaneous equations was asked by way of word problem. It's something that we need to become a little bit more well versed into. So I will be dedicating a whole lot more time going over word problems with you guys, because it's so important to be well versed in word problems so that we can be fluent in them and can have more confidence and become more skilled in answering word problems. So this was just a paper I was reviewing. All right, just for those who may have got here, we started off with numbers in the number system, identifying values of x which would make a particular expression either rational, irrational, and non-real. We looked at simplifying, binomial by trinomial, division of two fractions, okay, and how we employ factorization when we are dividing fractions in order to simplify things. Looked at simplification of exponents, right? Addition and subtraction of numerical base exponents where we have to factorize, apply highest common factor, splitting, highest common factor, and simplification, cancellation, exponential equations, linear equations, quadratic equations at this particular step, then solving for x, simultaneous somewhat equation, with a little bit of incorporation of substitution of variables in an appropriate place to solve for an expression and get a numerical value. We looked at inequalities, guys, never underestimating inequalities. We looked at an inequality, compound inequalities to be exact, guys. All right, and I shared a little bit about interval notation, how to represent answers on a number line depending on the question that is asked at a given moment. We looked at literal equations, okay, how to change the subject of the formula for various equations when we do have them, right? And then last but not least, we looked at a word problem that requires us to use our algebraic knowledge, express what we have read from the account in terms of letters and variables, and then solve for unknowns. Okay, so yeah, thank you, grade 10s. That was good. I am definitely now need to go and sleep. Thank you so much. Have a beautiful and wonderful night. And yeah, hopefully as your control tests come up, guys, you can actually look forward to a great time of getting amazing marks. But thank you so much. May me love and leave you. This is your host, Maths is a Game. Please, guys, if there's any sort of like departing gifts, I appreciate those, whether it be a you awesome, whether it be a rose, whether it be a whatever, man. Whatever is within your reach. Um, yeah. Anyways, yeah. But thank you again. It was good.